Hi, welcome everyone. My name is Levent Gördemir, UTA Planetarium Director. Together we are here with another live star stream of UTA Planetarium, and in the studio here is Jim Bader with me, Planetarium Program Coordinator, and he will be, I think he has great lined up news.
Yep, we have a
today.
ton of news today.
Great.
You did mention something you saw in the sky early this
Yeah, I
morning.
noticed two bright planets are appearing very bright in the roughly southeast direction of the night sky. If you can transfer me to the night sky, here are the two objects I would like to talk about today. If you see something or two bright things in the night sky early in the morning, those are one of them is Saturn, the second largest gas giant planets with great ring system around it. And the other one is going to be the largest planet of the solar system, Jupiter. Jupiter is also a gas giant, and you can just use a small telescope to look at it. You can really see the surface features like the brown stripes like these. Here is not even in the picture, it's on the other side right now, but you can see the great red spot as well. So the largest planet of the solar system, and I think that one of the news is about some of the missions to this planet, right?
Yeah, definitely. We got some Jupiter news coming up for sure. Actually, first thing, but go ahead. Yeah.
And even with a small telescope, you can see Saturn and Saturn's rings from Earth. Saturn is the only planet that we can see the rings with the telescopes from Earth. Other planets, other gas giant planets like Jupiter, for example, also have rings. But Jupiter and other gas giant planets' rings are so tiny, they are not visible from Earth. We were able to discover those rings with space missions in the past, but the Saturn's rings are big, bright. They are visible to Earth telescopes. All right.
Yep.
If you like, we can just continue with news.
Yeah, let's get straight into the news then. Let's get this switched over. So, news today, right underneath me, or where Levent's pointing, is the largest moon in the solar system. It's bigger than the planet Mercury, right? Am I wrong?
Yes.
It's crazy.
It's Ganymede. Yeah.
Yeah, Ganymede is huge, gigantic moon. Anyway, hello, Janet. Good afternoon to you too. And we are definitely going to talk about the eclipse. You can betcha. Lamia, awesome. Everybody's showing up. Good news. Yeah, so news on Juno. I'll pop out of the way, Levent. Juno orbiter makes its closest approach to Ganymede. And Juno is an orbiter that's going around Jupiter, taking some just fantastic photos of Jupiter itself. I should have had some of those queued up also, but just crazy high resolution. But as it is passing moons and other things, trying to widen its orbit to make really close approaches, it's also taking photos of these things. So
Yes, it's amazing that I forgot about Juno because it hasn't been, it was for a while. I haven't heard anything update from this spacecraft or orbiter. That was launched long time ago, and it took long time to approach to Jupiter, and it is a dedicated robotic mission to explore Jupiter. Because we are actually, because the space stuff takes time, we just started discovering our own solar system, and not long ago. I mean, I'm talking about like 1980s, 1990s. We just launched those initial primary spacecrafts like Voyager 1, Voyager 2, Pioneer 1, Pioneer 2, and they were just like a one-time shot to sweep out to the solar system and take pictures. And imagine the technologies with the camera systems. Resolutions were very low, but they turned in a very first close-up images of planets. Mostly they were in black and white and not in detail. But now we are sending spacecraft to explore individual planets. Like, for example, there was a Cassini mission which ended a few years ago.
Heartbreaking.
That explored Saturn, and Juno is exploring Jupiter. Like similarly, the recent rover is exploring Mars, and I think there is another mission planned for Venus. So right now it is the time for us to explore the individual planets with specific missions.
Yeah, and we're certainly doing that right now with this. This is actually Jupiter's second planetary mission. So we sent another orbiter called Galileo in the 90s, and that was the last time we've had a close approach to Ganymede, was actually in the year 2000. And it got closer than Galileo by a lot. I think at one point it came within like 200 miles of the surface, which is pretty crazy.
Absolutely.
The photos, the next photo, I mean, I guess I could switch. There's no reason I can't switch to the next photo. This photo is near its closest approach. This is Juno's closest approach, and we're about 620 miles above the surface, so still really close to it. But you can see so many things. I feel like brings up. It's way too soon to. What do you say? It's way too soon to really say that this means stuff. But what do you think about those little striation lines right here?
Well, I'm looking at the craters.
Very interesting craters too.
Yeah, those are all like the impacts, because as we talked before in different live streams, there's a lot of small size asteroids. Like there's one on my table over here, and they get to impact on these type of moons, and planets, especially the ones they don't have air around them, are vulnerable to those impacts. So it's amazing. But those features, it's hard to tell, but there may be some maybe icy features on the surface.
I think that most people are still saying we think that Ganymede is just an ice moon with subsurface ocean. But like you mentioned, we still actually know so little about these places, right?
Yeah, I think what we know for sure is the other moon of Jupiter, Europa, is an icy moon, completely covered by ice, and there is another one around Saturn called Enceladus. Enceladus is also icy moon, but according to the calculations, because these large gas giant planets, Jupiter and Saturn, have a big gravitational influence on these moons, they can actually warm up the interior of the planet. We talked about this process last week, how the moons and the planets are interacting the interior of each other, and they are just warming up each other's interior. So if it is warming up inside, that means it may be icy on the surface, and as you go down, ice will turn into water at one point. So in this case, we are talking about actually frozen lakes.
I think we have a really interesting comment from Kurt making this observation. It's definitely. We have a question from Kurt making a really interesting observation. I think it's definitely too early to make yes, this is true, but you can see his comment there. Very dense surface. Impacts are tight, not very deep. Maybe the depth is hard to see from here, but I still imagine they're pretty deep.
Yeah, the depth, I don't think we have a lot of information from just the picture, because we don't know how thick or how deep that the crater impact is. I think we need just some like maybe three-dimensional survey to be able to say that.
It's super interesting, though. I mean, you're not wrong in making these observations, Kurt. I think pretty crazy-looking stuff. I'm interested to this huge chunks of different colored stuff. So just underneath my portrait, you have a really dark, kind of rough-looking area, and then to the left of that, it gets lighter. To the right of that, it gets lighter, and then right next to Levin's head, you have an even lighter area. And what does this mean? Like, how does this happen? It's interesting. There's a lot of really cool features. that maybe in the coming months we get some cool info about.
Yes.
All right.
Let's leave the work for planetary scientists.
Yeah, definitely. We have some comments here. It looks like Lamia says, finally exploring Venus.
That is true. Finally, yes. I was also curious about Venus because Venus is the hottest planet of the solar system. So how does it get so hot? It's even hotter than Mercury. Even though it's not the closest to the sun, it gets more heat from the sun. And then we blame the weather or air around Mercury. I mean the Venus.
We just need to pop in real quick before we get to this next news article. Lamia said, "Is this the other side of the moon?" It looks like it. Not this right now, but before. If I can go back to it.
It was Ganymede, the largest moon in the solar system, also the largest moon of Jupiter. But yeah, this is not the backside of the moon, but backside of the moon actually is worse than this. There's a lot of crater impacts. So here is the probably good price question. So why the back of the moon is covered by more craters than the side facing to Earth?
I don't know. What? Oh, I mean.
Okay, we'll just. I'm not asking to you.
Okay.
I'm asking to.
Good. We'll see if they got an answer.
The Facebook watchers.
They're just gonna they're gonna Google it, Levent. Kurt's gonna go Google it, and can have no cheating.
I mean, that's also fine. That's also one way of finding or accessing information, rather than making it up, right?
True.
It's much better method if you just ask Google. That's fine. Google also is a reputable, I think, the information depository. Of course, you need to also know how to pull the right information. But anyway, Google may have an answer.
Yep. Okay. So I guess while they're making their guesses or
because
Googling
the
it,
sun's side draws them with gravity, he says it's wrong.
I think it's got to be
okay.
Related.
The question is, let me clarify the question. We have a moon, right? We call the moon. It doesn't have a specific name. It is just the moon. All other moons in the solar system have names. The Earth's moon doesn't have a name. We call it the moon. Anyway, the moon has a face siding Earth and has a face siding the other side. We don't see the other side one. And the other side of the moon is covered by more craters than the side facing us. So could it be due to gravitational force between Earth and the moon? Lamia says no. It's not related with the gravity either.
This is stressful. How about we give it some time and we go through Venus?
Okay, let's go to Venus.
A little bit.
Let's not go to the Venus. Let's talk about Venus. I would rather stick in Texas rather than going to Venus. It is too hot.
Way too hot. All right. So
right now, Texas, I think I'm comfortable with Texas temperatures.
Texas
it's
felt
around
yesterday.
like 80s, 90s. Today is a little
humid.
Yes.
The humidity yesterday and probably today, I haven't been outside much today, was awful. It was brutal. I think that's probably what Venus feels like. Subtracting, like 750 degrees.
I would still rather not to go to Venus.
Yeah.
So NASA is returning to Venus, the headline says, and 2 new missions.
Yeah, 2 new missions. It's been like 30 years, decades plural, since we have sent any missions to Venus, and this with new administration, this new turnaround, they're actually going to send 2 missions to Venus. This brings up like that age-old thing where Russia was successfully sending missions to Venus, and the United States, Soviet Union was successfully sending missions to Venus, and the United States was successfully sending them to Mars, and we both failed at the opposite so many times.
Okay, here is another question. I'm the one asking questions today, huh? We are exploring Mars for life. to find possible life. So how about Venus? What are we looking at on Venus?
That's a great question. I mean, one of the missions called Da Vinci Plus. I don't know if I need to say plus, but it's in the words. It's actually going to check the atmosphere for whole bunches of things, but to see if Venus ever had an ocean or surface water of any kind. So if there's any evidence that says that's true, that's going to be really neat. I want to make a joke a bit about these things. One's called Da Vinci, spelled correctly, and its name, that's just an acronym for, let's get this right, first try. All right. Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging.
Noble gases. What are noble gases?
Ones who have lords and ladies, castles.
No. Let's talk about the Venus. Venus as a planet. So like there are string differences between Mars. Like we have two neighbor planets, two close planets to us. One is Mars, one is Venus. Venus is the size-wise and also gravity-wise pretty much like Earth. They are very comparable planets, but Mars is not. Mars is a small planet. It is about half size of Earth. So if we are looking at like the two planets, we are comparing two planets as a planet going around the sun. Mars and Earth is not really are brothers or sisters or not twins, but we can say this planet is twin. But this planet has a trouble, and that trouble is there is a lot of carbon dioxide in the air around Venus, and that carbon dioxide tends to form thick clouds, and those thick clouds are absorbing a lot of heat but not releasing them. So that is working like a giant blanket around the planet and warming up the planet to a degree that it renders the planet inhabitable. We are talking about like 900 degrees if you would like to go there. That's why I don't want to spend any vacation on Venus, because it's 900 degrees. So it's cooking. So the cookies baked at like 400, 450.
Would be rough cookies.
The Venus temperature doubles your oven's average temperature. So it's not a pleasant place. But so how come this planet became to this point? That is an interesting process. And also, since I mentioned we are blaming the carbon monoxide for this, we call this type of gas emission gas on our planet. And on our planet, as we live, every day we are releasing a lot of that gas into our air. So yeah, we are talking about this is one of the maybe the biggest reason of global warming. We are warming our planet's climate, and the biggest blame is for the human activity. And if that's the case, that's the carbon dioxide. Because if we burn anything, the carbon monoxide and carbon dioxide gases are released into the air, and we are doing that so by running plants and driving cars and everything.
Yeah.
So this planet is going to be very interesting to explore from that fact, because apparently, I mean, I don't think we can blame maybe like past civilization or anything on this planet, but we would like to know the processes that brought Venus atmosphere into this point.
And truly made it like a, to quote NASA's number 2, a hot house. It is a hot place. Kurt, you said it. Noble gases have full outer rings of electrons. I call them noble. They don't need any other stuff to do what they do, right?
Yes.
They can be by themselves. Second mission called Veritas, which another ridiculous acronym. It stands for Venus Emissivity Radio Science, INSAR, Topography and Spectroscopy. All those words you know, except for probably INSAR. INSAR is like, it's kind of what they do to check for volcanism, just watching the surface to see if even the tiniest little movements go up and down of the surface. So they can check for stuff like earthquakes
Mhm.
and volcanoes pushing up on the surface.
Mhm.
Anyway, this one's going to map the surface, check for volcanism, like we mentioned, map rock types, so we can learn about what it's made of.
Mhm.
Could be really interesting.
Yeah.
And the biggest benefit to us, Levent, is it's going to give us 3D topography, which means when you come to the planetarium, when we open, you get to see mountains.
We will be able to fly virtually on Venus.
Yeah, it'll be awesome.
And also another the difference is, well, this is pretty much Earth-like planet, but it's a moonless planet. And the Earth has one moon, and Venus doesn't have any moon. And by knowing the interior of this planet, we can just compare having no moon versus having one moon. So this is going to be interesting.
Yeah.
So it's going to be like taking a long time over the years, maybe in a few decades we'll know more about Venus. But again, I mean, space exploration takes time.
Mm-hmm. Definitely.
Even going there takes time.
Definitely. All right.
Eclipse.
Do you want to unstress them out? Looks like Lamia.
Okay, I saw actually right answer somewhere. Janet said, yeah, the back side always faces out. The other side always faces in toward Earth, so it's protected by Earth on that side, and that is the correct answer. So the impacts are coming from the other side because the side facing Earth is shielded by Earth. So the asteroids are not likely bounce back from Earth's surface, so they are likely not going to hit to the side facing us. So that means the new craters are always on the back side, and the side facing us are pretty much like coming from the old times of the moon's surface. There are not many impact craters on the side facing us, but the other side is pretty much looking very craterful.
Yeah, definitely. It is crater full.
Yes.
For sure.
That's probably the word I invented, right?
Yeah. I think
Craterful.
you did. All right.
Full of craters, that means.
Next up on the agenda is we got an eclipse.
Seems like solar eclipse.
Ignore that. Ignore that. Yeah, solar eclipse. We are having a special type of solar eclipse.
It's tomorrow, right?
It is.
June 10. Yes,
Super
tomorrow morning.
Early in the morning. If I can just slide this photo over.
We are not going to be able to see it.
No.
Because it happens usually most of the time places like these.
Yeah, it's gonna happen at 9:45 UTC, which means 5:45 for the East Coast. Yeah, that's really early.
Even before sunrise.
Yeah,
for us.
Definitely, which is I think probably why we can't see it.
Mhm.
Anyway, if you live in New England, you know somebody who lives in New England, they can see it. Lucky for them. It looks like most of New England's going to get some amount of it. And annular eclipses are a special type of eclipse, and I think maybe my favorite. I've seen both now, and I think just the ring of fire looks so awesome from this. Do you want to explain what it?
Yeah, but before I also heard one of the best places are going to be Canada.
Oh yeah.
But don't try to go there because the Canada borders are closed for non-essential travel.
Yeah.
So if you just go there and say, "Hey, I'm going to just watch the solar eclipse," they are going to say no.
Yeah, I think in totality, I don't have totality brought up on this map because you can't see it in any of the U.S. But it kind of pops up in the center. I don't know if you want to point to it. The center of where this little dark orange bulge is. Just Canada. Canada gets it. That's it.
Okay, let's talk about solar eclipses and ring of fire.
Sure.
What they say,
Yeah.
ring of fire, or we say annular solar eclipse.
So these images, I got all of them from timeanddate.com. They're just so good looking. This kind of explains. You take it away.
Okay, so the solar eclipses may seem a little complicated, but it is pretty as simple as just the moon is going in between Earth and the sun, and because the sun is the only the source of light in the solar system, if it goes in front, it blocks the light for a short time, and then the day turns into evening. We can even see stars, great, and we call it solar eclipse or total solar eclipse. So, well, the moon orbits around the sun, and why it doesn't happen every month, like every 1 month, we should, according to like a 2D drawing like this, we should see one solar eclipse every month. But it doesn't happen because the universe is three-dimensional, and the moon is either not in alignment with the sun, either little high or little down from the alignment, so it just misses every month, so we don't get to see one solar eclipse. However, in some certain specific times, the moon, just like here or here, perfectly lined up with the sun. In this case, it is blocking the sunlight, and we see solar eclipse.
Yep.
Well, if the moon is other side, so from the Earth, it is now full moon. If this type of alignment happens, then the sun is not blocked, but the moon goes into the shadow of Earth, and it disappears from the sky.
I think these always happen in conjunction too, right? When there's it's like for there to be a solar eclipse, there's a lunar eclipse right before it or after it or something.
Yes, and we talked about the lunar eclipse just last week, right?
Yep.
So in that perfect alignment, if the moon is here, it's in shadow, it just disappears from the sky for a short time. We call it lunar eclipse. And if it's on the other side, it blocks the sunlight. So lunar eclipses are visible from the everybody from Earth, but the solar eclipses are not, because the solar eclipses, the amount of the sunlight it blocks, actually because of the size of the moon is small, it is putting the shadow of the moon only a small certain spot on the surface of Earth.
And then annular eclipses in particular are even more complicated than that.
Yeah, well, the time to time we are talking about supermoon, right? So that's always in the headlines, the supermoon tonight. So supermoon, full moon. Well, we could talk about supermoon because the moon is orbiting around Earth, and it has elliptical orbit. And that means sometimes it is getting closer in its orbit, and sometimes it is getting farther in its orbit. When the moon is in the closest point, we call it perigee. Yep. And when the moon is in the other point, the far point, we call it apogee. So, this change affects the size of the moon, the visible size of the moon, slightly.
This just blows my mind a little bit. How? I'll let you get to it, but I'll interrupt you later.
Sure. Well, coincidentally, the average size of the moon and average size of the sun visible in the sky are the same. So if they are on their average size, and if they just go on top of each other, the moon perfectly covers the entire sunlight.
That just blows my mind.
And then we don't get to see any light from the sun. So that's what we call total solar eclipse. However, if the moon is a little bit at farther point in its orbit, and it is apparent size in the sky is slightly smaller than how large the sun is in the sky, then it doesn't get to cover the entire surface of the sun, and still there's like a ring of light. I think you have a good picture for that. Yep. Ring of light still leaking from the sun towards Earth, and that's what we call annular solar eclipse or ring of fire.
And here's the ring of fire, hopefully. Okay.
This is not a partial eclipse. Partial eclipse is a completely different thing, but this is the annular eclipse, or I think they like inventing some publicly understandable words, and somebody just came up with ring of fire, pretty much like supermoon. Supermoon is not also an astronomical term or scientific term, just like ring of fire either. But yeah, this is what they call ring of fire. The apparent size of the moon is slightly smaller than the apparent size of the sun. The sunlight gets to leak from the sides.
This looks so much cooler to me. This was taken in 2012. We had an annular eclipse here in North Texas from Wolfforth. That's hard to say. I think that's a small town outside of Lubbock. And you can see the photo credit beneath us. But I got to see this myself. I pulled over on the side of the road. I actually lined up my iPhone at the time with a pair of binoculars and got a very lucky photo, but it was not, it's not even close to how beautiful this one is. Just
I like the Kurt's comment says his eclipses that inspired by Johnny Cash.
Oh boy.
He also said you can always take a short early morning charter flight and catch it in the air. Yeah, it's possible. And a few years ago, I was actually I came across to an ad who somebody just organized a charter flight to watch a solar eclipse in the air.
If only we had that much money to just go up. And speaking of just going up in the air and money,
Yeah, they are two relevant things, going into the space and money.
speaking of money, that was a perfect. You and Kurt just lined it up for my next news article. It's not really news. It's nothing spectacular, not astronomy related. I thought it's confidence in your ability. Jeff Bezos announced that he would be going with the very first crewed flight of the New Shepard. So this is his rocket. Jeff Bezos is the CEO and I guess founder of Amazon.
So did they pick the July 20 dates purposely?
Yeah, definitely. What I couldn't find anywhere, I'm sure it's out there, is where it's launching from. Because all of their test flights have been from Texas, like middle of nowhere Texas. So I was like, are they going to launch from Texas? I couldn't find any concrete. So I don't know. I'm really sad to say. But this spacecraft is specially designed. If you guys can see the capsule up there, it has got gigantic windows. The whole purpose of this craft is to launch rich space tourists just barely into space and give them a few minutes of zero gravity and then land them in the desert.
I wonder if they put their company logo on the...
A little Amazon?
Yeah.
The company. Well, this is another one of his companies, Blue Origin. But yeah, it's still kind of Amazon. Right. We have a question from.
Yes. Are solar eclipses less frequent than lunar ones? Yes, they are. Well, they are not very rare, but the solar eclipses they happen about four times a year. But it happens in different parts of the world because, as I was trying to explain in the previous slide, the solar eclipses, during the solar eclipses, the moon's shadow falls into a very small point on the surface of Earth. For that reason, it's not visible to everybody on the planet. It is just visible to a small part of the world. Well, if you think about 75% of our planet is covered by water, most of the time solar eclipse observation places falls in the middle of ocean.
You could say this is a very average solar eclipse in the example, straight to the ocean.
Yeah. What we are looking is it falls on a land, and that land is a civilized land, not like in the middle of Antarctica that we can travel. And also, the sky is clear. It's a whole different story. By the way, in 2024, the solar eclipse is going to be in the Dallas-Fort Worth area. Arlington is at the center of the totality path, which means Arlington will be at the center of this shadow zone, and that's going to be a big event. Hopefully, the sky will be clear.
That would be so devastating event. I mean, we've already kind of had some light planning on this, and we're expecting this to be enormous, and I cannot begin to describe how frustrated I would be if there were clouds.
And going back to the question, yes, the solar eclipses are less frequent, but also we are not coming across to one easily because of all the the small area, civilized area, not middle of ocean and things like that. But lunar eclipses are more frequent because they are visible to pretty much everybody on the same side of the planet, and the lunar eclipses are also happening uh, and we can see. We can all get to see. We
Yeah.
don't have to be a specific place to see the lunar eclipse. If it falls to the right, the time window, of course.
Anyway, that's all I have, news-wise. We're only a little over this week, so that's good. 6 minutes, we're doing better. Last week was out of control.
But I think last week our audience kept us longer, right?
Yeah, it's
Here?
their fault. Their fault. I should get paid overtime for that.
So when are we gonna get to speak about UFOs?
We're supposed to just brush that under the rug. No, we have some stuff lined up for you guys. We're working on it. We're gonna try to maybe bring in someone special.
No, because I just saw a headline that Air Force will give a presentation in the Congress by July 20. They said.
I
Well, 50 years thing is over. You know, they are just started unclassifying the classified documents. Not that I'm saying that they haven't any like a UFO evidence. Don't get me wrong. They don't have any evidence. They say such thing doesn't exist. But they are explaining some mysterious lights or some strange flying objects.
I think that's such an important thing in science, right? We know basically very little about the universe. And there's tons of things that happens that we don't have a concrete explanation for. And so it becomes a UFO because we didn't know for sure.
But because of all the public demand,
but we can have good explanations.
Unclassified the Roosevelt incident earlier than 50 years because that was I think that there was a lot of public pressure about what it was, and they said, well, that was a special military balloon carrying some significant sensors to detect some nuclear activity, nuclear weapon activity around the world. So they are not classifying these type of information, but I think it is more important. I'm not interested in whether it's just unidentified flying spacecraft or similar objects flying in the space. I think it is more interesting to know what is the possibility. What is the possibility of thinking that there's an extraterrestrial life and they are intelligent, and what is the possibility they can actually come and ride in those flying saucers and make appearances and things like that.
Then, like we mentioned, this means 2 episodes. We got to have 1 episode on how it's possible to get here. We'll get some kind of high-energy physicist in here to talk to us about it.
Yes.
And then we will talk about UFOs or aliens, extraterrestrials. This is coming soon, folks. So
or
stay tuned.
generally life in the universe.
Okay, I like. Maybe an astrobiologist.
Mm-hmm. That's a good idea.
We got a couple. One of those on hand.
Yeah.
Kurt says, thoughts on China's fusion reactor east. I don't know anything about it. I don't know if Levin does. But fusion power is powerful if you could get it to work.
Yeah, that's he explains what it is. That's the kind of thing that can power an interstellar cruiser.
Yeah.
For like interstellar possible spacecraft, the Einstein's relativity theories are actually going deep into that, and that's what we try to explain if the warp speed may be possible. So, universe is too big for us to travel. I mean, imagine even like traveling right now. It's summertime. We are making travel plans, right? And traveling. Even on our planet is hard. I cannot imagine traveling to a different star. But if we can solve enough physics mystery, like first thing is why we cannot go faster than speed of light. We cannot even go at the speed of light. So we can talk about those.
Yep.
All right.
Okay. So, cool. That's it. One last comment from Kurt. If we can do it, those UFOs might be doing. Yeah, if we can't, I don't know. We'll see. I don't think there's
Yeah.
really good, effective, proven results from fusion or fission. Now I'm a little confused. I'm getting out of here. I'm pulling. I don't know what I'm talking about.
All right. So let's take a break, take a 1 week break, and we'll be here next week.
Yep. Thanks so much.